Bismillahirrahmanirrahim. Assalamualaikum. So this video is going to discuss on the solution for example 1 and example 3 from the induction motor slides. Example 1 is for star connected induction motor and example 3 for delta connected induction motor. So a 15 HP, for example 1, a 15 HP for 15 volt, 50 Hz, 4 pole, 3-phase star connected induction motor operates at 1465 RPM when carrying rated load. So let us do some listing. So 15 HP, so we have 15 HP for 15 volt, 50 Hz, 4 pole, 4, and then it's a star connected motor, operates as 1465 RPM when carrying rated load. So first you need to identify what are the given information. Basically it is okay, for the first one 15 HP. Okay, remember for induction motor converts from P electrical into P mechanical. Okay, so electrical the unit is watt, mechanical the unit is horsepower. Okay, so this is your P in converted into P out. So actually the given 15 HP is your P out, but what P out? It's a P out rated. Okay, just like I've explained before. So usually they will give you the rated value. Okay, so for 15 volt is the V rated. Okay, now your induction motor is 3-phase. So 3-phase we have line value and phase value. Okay, V line, I line, V phase, I phase. So for 15, if it's not stated whether it's V line or V phase, so that is your V line rated. Magnitude saja lah, only magnitude because the angle is not given. So 50 Hz is a frequency, electrical frequency. 4 pole, so number of pole is P is 4, and then it's a star connected. Okay, why do we need to state here star? Because we must highlight the relation of voltage and current for star connected motor, just like in chapter 1. That is for star, I line equal to I phase, V line equal to square root 3 V phase. Angle of V line you must plus with 30, because we will definitely use this later. Okay, so it's better for you to highlight it first. Okay, so 1465 RPM, it's a speed. Okay, the question said that the motor operates at 1465 because of the sentence. From the sentence, the motor operates, so that in induction motor we only have two, not that we only have, we have two main types of speed. Okay, remember, and synchronized speed and motor or rotor speed. So this one is sometimes written as, okay, so from the sentence the motor operates at, so that is actually N motor or N rotor. Okay, so that is your NM or NR. Alright, and carrying rated load. The motor parameters refer to the stator expressed in ohm per phase R. So in the previous video I forgot to mention that the approximate equivalent circuit included in the slide is actually referred to the stator. Okay, the standard approximate equivalent circuit that is included in your syllabus is the one that is referred to the stator. The same concept as in transformer, we have referred to primary, referred to secondary. So in motor we also have the same concept, since the winding on the rotor is not physically connected to the winding on the stator. Okay, so we to use the same voltage level, we have to refer. So for your syllabus, you don't need to pening yourself, because you only have one approximate equivalent circuit that is referred to the stator. So from this sentence, you don't worry, you just repeat the statement that the approximate equivalent circuit that you are using is referred to stator, and the parameters given in ohm per phase are, okay, this is XM is 31 ohm, XM, you can refer to your slide, yeah. Okay, so everything is given. Okay, so if it's for me, I would suggest you to sketch, yeah, based on the value, sketch the equivalent circuit first and label them lah. Okay, for induction it's very simple, because we only use one circuit, one approximate equivalent circuit. Okay, you may refer to the circuit in the slide. So in front here we have phase, I1 phase or stator phase current, I0 phase and I2 phase. And here we have RC, JXM, R1, JX1, JX2 and R2 over S. Now it's time for you to label. Okay, that's the given value. Okay, in the lecture note, the element is given in 1 or 2. That is 1 for stator. Why 1 for stator? Because your input or your electrical power is injected into the stator. That's why input U is at the stator. So 1 referred to stator, 2 referred to rotor. So R1 equal to RS, that is 0.3 ohm. XS 0.83, that is J 0.83 here. Okay, and then RR, that prime is actually a symbol of rotor referred to stator. No need to worry. So that is 0.31. So RR is R2. So 0.31 here. But we don't know yet what is your S, so leave it blank first. And then we have XR, that is equivalent to X2, that is equal to 1.25. So this is 1.25J. What else? Okay, given as well is XM31. Okay. M31. Okay, if you notice, the value of RC is not given. So if in this case, we can assume that RC is equal to not equal to 0, but we can assume that RC, write down here, equal to infinity, because we know that RC is the resistance of the core, and that core is not conductor, so the resistance is very high, very big. So if it's not given, we assume it as infinity. So if your resistance is infinity, so it becomes open circuit. So actually you need to erase this, so it will become open circuit. Yeah, hope you can imagine. So I not phase only flows through XMJ only. Alright, so that's the equivalent circuit. Okay, moving on. What's next? Okay, before we go to the question, another given information is the total rotational loss 11000 watt. So P and are assumed to be constant at rated voltage and rated frequency. Fine. So just add here extra information. P rotational loss is 1100 watt. Okay, please jot down any information given. Yes. Okay. Now the question is, find the motor slip. So you can find the formula from the slide. Motor slip number 1. Motor slip, not slip speed. So motor slip S equals to NS minus NR over NS. So you have NR already, that is equal to your NM lah. That is 1465. Yes. Okay. But you don't know yet your NS, so you need to find. So formula NS is 120 F over P. So your F is 50 plus, so 120, 50 over number of pole is 4. That is equal to 1500 RPM. Remember, if you are using the formula for N, the unit is RPM. So now you can find your slip. Easy peasy. 1500 minus 1, this one, 1465. 1465 over 1500. So you'll get 0.023. Okay, remember your slip must be between 0 to 1. So if you get this kind of value, that is correct. If you get more than 1, then something is wrong with your formula. Okay, so number 2. Okay, settle. Number 2. The stator phase current. Actually in the slides, I'm not sure. I think it's not stated as phase current. The question only state the stator current. Okay, first. Stator, we know that I1 phase is your stator phase current, right? But actually the question didn't mention phase online because your motor is star connected or Y connected. So I line equals to I face, I1 face equals to I1 line. So no need to mention whether the question want face or line value, because they give you the same answer. So just calculate your I1 face is enough. That is okay. So the formula for I1 face, KCL equal to I0 face plus I2 face. So I0 face equals to this V face divided by whatever impedance you have here. So since we only have XMJ, that is 31J, just divide by 31J. But before that, V face. Okay, so in this formula you need your V face, right? But the given one from the question is V line. So you need to find your V face. You can't simply use V line, because for star connected motor, see, V line is not equal to your V face. You need to find your V face. But again, because V line, angle of V line is not rated, it is not stated. The question only give you the magnitude. So we can use the assumption that we can assume V face U yang is at 0 degree. Okay, never mind. Okay, write it down here. Okay, V line, magnitude of V line equals to square root 3 magnitude of V face. Therefore, magnitude of V face equals to magnitude of V line divided by square root 3. That is 415 divided by square root 3 equals to 239.6 volt. Then only you can insert it into the equation. So this is 239. Okay, let me write the general equation first to make you guys less pening. Okay, V face. Since we don't have RC, you don't have to parallelkan RC and XM. So just you are left with XM plus I2 face is V face also, but divided by R1 plus JX1 plus JX2 plus R2 over S. Okay, then you insert the value. Right, so 239.6 divided by J31 plus 239.6 divided by, so actually we assume V face U is at 0, yeah. This is what I meant earlier. Okay, if the angle is of V line from the question is not given, we can assume the angle of V face is at 0. Okay, if it's stated, then you have to use that formula. Okay, now and then R1 is 0.3 plus X1 is J0.83 plus X2 is 1.25 plus R2 of S. Your R2 is 0.31. Your S from the previous question 0.023. Close bracket. Okay. Before that, I would like to remind that this part is important, yeah. If it's star connected, you have to convert from V line to V face. But if it's delta, since we know that V face equal to V line, you don't have to convert V line into V face because they are the same. So for star, make sure you convert according to this formula, yeah. So the answer is, okay, please write down your answer separate. Write your final answer for I0 phase and then followed by I2 phase in polar. Because usually later we'll be using a magnitude. Just magnitude to calculate certain power, right? So write your answer in polar. 7.73 angle negative 90, 17.2 angle negative 8.58. So last one, your I1 phase equal to 19.88 angle negative 31.2 ampere. Okay, I'll stop this video here for now. Okay, we'll continue the next 3 questions in the next video.